if you're speaking during this part. Okay? So folks, here we go. We're going to dive a little more into geometric series, and that's what we looked at yesterday. I just want to firm that up a little bit more. So again, first our reminder is that when we're talking geometric sequences, series is when you add them up. We're doing that on Monday. So sequences is just a list of numbers. So when we're doing geometric sequences, we're looking at a list of numbers where we're multiplying or dividing by the same amount each time. Call that our common ratio, and that allows us to get our next term. So of course our formula is our starting amount, that's A, times our common ratio, that's R, and we put that common ratio to the exponent n minus 1. Okay, so that's stuff we did yesterday. I want to go over a couple of the homework problems that were suggested. So I'm going to look at 3 parts from question number 7. Part B, D, and F. And so question 7 says, determine whether each sequence is arithmetic, geometric, or neither. If a sequence is arithmetic or geometric, state the general term. So if we can figure out if it's arithmetic or geometric, we're going to go for that general term. So here's how we can figure out if it's arithmetic or geometric. First thing we can do is, if it's arithmetic, if we subtract 2 consecutive terms, say the 4th term and the 3rd term, well, the 4th term is negative 189, and the 3rd term is 63. So if we subtract those, we're going to get negative 252. Now, if it's consistently negative 252, then we know we've got an arithmetic sequence. It's not looking good. Let's try the next one, the 3rd term minus the 2nd term, just to see if this holds true. 3rd term is 63. The 2nd term is negative 21. So I'm subtracting a negative. That's the same as adding. So we're going to end up with 84. So I noticed that my common difference, there's no common difference. There's differences between the terms, but it's not common. It's not the same for each of them. So that's my problem. I know it's not arithmetic. So I'm going to say here, no common difference, not arithmetic. So no common diff, therefore not arithmetic. And you could probably tell that just by looking at it, but I wanted to make this nice and clear. Okay, so maybe this is a geometric series. Maybe we are multiplying by the same thing to get from one term to the next. And how we can figure that out is we can just look at it and try and see if we can figure it out. But if I want to do it kind of formally, I'm going to take the 4th term and I'll divide it by the 3rd term, the one before it, and we'll see what we get. So that's negative 189 divided by 63. And that's going to give me an answer of negative 3. And then I can try again. What's my 3rd term divided by my 2nd term? That's 63 divided by negative 21. And that also gives me negative 3. It looks like that's true for all of them. So negative 3 is going to be my common ratio. So I'll just put an R here for common ratio, and then I'll put a negative 3, and then I'm going to put a nice big box around that. I can also figure out what my first term is, because I say, okay, my first term is 7. So this is a geometric series. It's changing by being multiplied over each one. So now we need to find our general term. Well, to do our general term, let me pick a new color here. When we do our general term is just our starting term times our common ratio to the power n minus 1. That's what we use for geometric series. So our starting term is negative 3. I'm going to put it in brackets just to make everything clear. And that's going to be times 7 to the n minus 1. So that's it. That's our general term. Can't simplify that anymore. Looks nice and lovely. And we're off to the races. Let's try another one of these. Actually, another 2. So determine, again, same thing, whether it's arithmetic, geometric, or neither. So for our first one, I'm going to try and see if it's arithmetic. So I'll go my fourth term minus my third term. That's 37 minus 34. So that's a difference of 3. And my third term minus my second term. That's 34 minus 32. So that's a difference of 2. Before that, it's a difference of 1. So it's not, so I say there's no common difference. So that tells me that it's not arithmetic. Let's see if it's geometric. Let's go my fourth term divided by my third one. That's going to be 37 divided by 34. So that's going to be some decimal number, 1.0882. And let's try my third one divided by my second one. So that's 34 divided by 32. Let's see what we get for that. That's going to be 1.0625. So those are not the same. So there's also no common ratio. So therefore, this is not arithmetic or geometric. It's some kind of other. So I'll say therefore neither arithmetic or geometric. Because it doesn't have a common ratio and it doesn't have a common difference. I'll put a little line there to keep those separate as well. Okay, for F, same deal, but let's move kind of quick because we've done a bunch of them now. So I'm going to notice there's no common difference. There's no common, like, it's subtracting each time, but it's not subtracting by a common amount. So I'm just going to skip that first part where I look for a common difference. I'm just going to look for a common ratio. So let's go our fourth one divided by our third one. That's 54 divided by 72, which is 0.75. And if I do the next one, my third one divided by my second one, I get the same thing. Now I know that 0.75 is 75% or 3/4, right? It's the same as 3/4. So if I wanted to write it in fraction form, I could write it like that. If you prefer writing it as a decimal for this, it's fine. It's not a big deal to have it as a decimal. But I kind of like having it as a fraction for this. So I'm going to say, okay, my general term is going to be my first number times my common ratio to the n minus 1. Well, my starting term is 128, so I can sub that in. And my common ratio is 3/4. And I'll put that to the n minus 1. And that's it. Now I got my general term, and I know it's arithmetic. All right, geometric, rather. Geometric, because it's multiplying each time. Okay, so thank you to those who suggested that bit of homework. I think that was some good stuff to go over. And I appreciate that you wanted that looked at. So thank you for suggesting those. All right, we're going to do a couple more examples of our geometric series. So I'm going to do one, and then I'm going to have you do one that's very similar. Okay, so this is the watch me, and then in 2 minutes or whatever, you're going to try one that's basically not identical, but really close. Same type of problem, just with different numbers. Okay, so I've got 2 different ones here. It says determine the general term and the 9th term. So I can tell just kind of by looking at these really quick that these are geometric. I could do the thing where I divide the 4th term or the 5th term by the 4th term and then divide the 4th term by the 3rd term and so on and so forth and see what I get. But I can just look at them and I can tell, okay, this is getting cut in half each time. So when I go from 16 to 18, what am I multiplying by? You might say, well, you're dividing by 2, Mr. Roy. And I would say, yeah, you're 100%. I'm dividing by 2. But what do you call that when you multiply? It's the same as multiplying by a half. dividing by 2 is the same as multiplying by a half. And if I did my T5 minus T4, I'd get a half. So my common ratio here is 1/2. Each time I'm multiplying that number by a half. And what's my A value going to be for this? That's my starting number. Well, that's nice and easy. I have it right there in my sequence. It's just 16. So once I figured out what those two are, now it's just a matter of getting my general term. So I'll say, okay, my general term is my starting term times my common ratio to the power n minus 1. My starting term is 16. My common ratio is a half. And that's to the power n minus 1. So now I want to find the 9th term. So let's do that. Let's sub in a 9 wherever we see an n and see what we get. So 1/2 to the 9 minus 1. So 9 minus 1 is 8. Now you could plug 1/2 to the power 8 into your calculator. In fact, I'd like you to try that right now. Make sure you put the 1/2 in brackets so that you're not actually doing like only one part of it to the power 8. So put the 1/2 in brackets and put it to the power 8 and you'll get some decimal. Check it out and try it out right now and see what you get. So you should get some big long decimal, 0.00390625. That's not super useful to us. I guess we could just plug all that in and get into the decimal number, but I kind of like to use fractions if we can. So here's a little aside. I'm going to erase this in a minute, but I know that 1/2 to the 8th is actually this, right? Did I get 8? 1, 2, 3, 4, 5, 6, 7, one more. It's really that, right? So our shortcut was that we can take the exponent and we can apply it to the numerator and the denominator of that fraction. That's going to be kind of like a shortcut for us. So when we actually write that out, we're going to say t to the 9 equals 16 times 1 to the power 8 over 2 to the power 8. And 1 to the power 8 is just 1, because it's 1 times itself 8 times. 2 to the power 8 is going to be 2 times 2 times 2 times 2 times 2 times 2 times 2, etc. So 2 to the power 8, that's actually one I don't have memorized. 256. 256. So now we just need to multiply 16 times 256, and there's our 1 over 256, and there's our answer. I could write this as like this, and I could simplify my fraction by dividing both the top and bottom by 16. And it's actually going to work out to 1 over 16. So if you plugged all this into your calculator and just got a decimal number, that's totally fine. You would find that that decimal number actually equals 1 over 16. But if we want to be a little more elegant, we can keep things as fractions. Okay, so that's my 9th term, is 1 over 16. And since every time I'm dividing by half, my 10th term would be 1 over 32. And then my next term would be 1 over 64, and so on and so forth. Okay, let's try another one. This one on the right-hand side. So for this one, I need to try and figure out what my R, the common ratio, is, My starting number is nice and easy. That's 729. Now I notice the sign is flipping, right? This number's positive, this number's negative, this number's positive, this number's negative. So the sign is flipping back and forth. That means my common ratio must be negative. And I see each time it's getting divided by 3. That means my common ratio is going to be 1/3. Now if you say, hey Mr. Roy, I can't just come up with that on my own, I need a method for doing that, then I say totally, that's a great suggestion. The method we would use is exactly like we did before. We'd say our fourth term divided by our third term is negative 27 over 81. That's equal to negative 1/3 when we simplify our fraction. And our third one divided by our second one is 81 over negative 243. And again, that equals negative 1/3 when you simplify the fraction. Okay, so that's how we got our R value of negative 1/3. I'm just going to move that out of the way so you have a nice bit of space to work with. Okay, so let's go and figure out our general term. General term is going to say, general term is the starting amount times the common ratio to the power n minus 1. Starting amount is 729. Common ratio is negative 1/3 to the n minus 1. Now if I want to figure out the ninth one, I just plug in a 9 anywhere there was an n. Kira, I'm not sure if you can hear me. I see you said your computer shut down and you can't join back. I'm just going to ask you to try and shut down Teams if you can and see if you can restart it and join back in. If not, I'm recording this, so you'll be able to check it out later. Okay, so this is going to be negative 1/3 to the 8. And you could have that negative sign on the top or bottom of the fraction. It actually doesn't matter. It's not going to change anything. So top or bottom is okay. Some people just like to put it out front. So now I've still got my 729. And now I've got to take that fraction and I've got to say, okay, I got to apply that exponent to the top and the bottom. So on the top of that fraction, I'm going to have negative 1 to the power 8. And on the bottom of that fraction, I'm going to have 3 to the power 8. So this is harder when you've got decreasing sequences. It's easier when they're going up. The fact that my R value, my common ratio, is a fraction is because my values are going down and it's tougher to work with. If you get one that's going up, it's just going to be easier to work with. Okay, negative 1 to the 8. Now, I know 1 to any power just means 1 times 1 times 1 times 1 times 1. It's just going to be 1. But because it's a negative, it's a little more complicated. So I know that a negative times a negative gives you a positive. And I've got 8 negative 1s. So that means anytime I've got an exponent that's an even number, all of those negatives are going to cancel out. And it's going to end up being a positive number. But if I've got an exponent that's an odd number, like 7 or 9 or 11, then all the negatives would cancel out except for 1, and I would still end up with a negative number. So negative 1 to the 8th is just going to turn into 1. It's going to turn into 1. And 3 to the 8, it's a big number, 6,561. So I could write this as a fraction, which is 729 over 6,561. Now you could just divide those two, write it as a decimal. That'd be fine. But it's kind of nice to leave it as a fraction and simplify it, and you can actually divide both top and bottom by 729. And this actually works out to 1/9. If you just did it as a decimal, you get 0.1111. So that's my 9th term. Okay, I want you to try this. I know these are a bit tricky, and that just means we need practice, right? So I'm going to flip to the next page here. I'm going to pause our recording. Now you'll notice these ones are going up, which is going to make it a little bit easier because we're not dealing with a fractional R value. So they're going up by a certain amount each time. You'll notice the second one has some negatives in it. It goes negative, positive, negative, positive, negative, positive, which means our common ratio is going to be a negative number. Okay, so I'm going to pause the video here. I'd like you to get to work. We're going to take about 4 minutes for you to try and practice this. Ask me questions as we go, okay? All right, so we're dealing with geometric series here. If you didn't already know that, you would have to check and see if it's arithmetic, geometric, or another kind. In this case, I know it's geometric, and I can see that when I divide each term, I'm going to get a number of 4. So basically, it's being multiplied by 4 each time. And if I did my 4th term divided by my 3rd term, I get 4. My 3rd term divided by my 2nd term, I get 4. So my R value, my common ratio, is going to be 4 for this. My starting value is going to be 2. And since these are going up, my sequence is increasing. It's going to make this a lot easier because I don't have to work with any fractions, which is nice. So we say, okay, our general term is our starting number times our common ratio to the power n minus 1. So that's going to be 2 times 4 to the n minus 1. And if I want to get my 9th term, I've got to put a 9 in there. So to the 9 minus 1. So that's going to be 4 to the power 8. So that's probably a calculator job unless you've got a brain that likes doing computing like that. Mine can't do that in my head. I can't do that in my head, at least not without a bit of time and a bit of work. So remember, we're not doing 2 times 4 to the power 8. We got to do 4 to the power 8 first, right? Exponents need to come first. So don't multiply that 2 in, because then you'll also accidentally put it to the power 8, and it's not. Only the 4 is. So do that 4 to the power 8 first. So that's going to be 65,536. And then we're going to need to finish multiplying by 2. So we're going to end up with 131,072 is our 9th term. Over here on the other side, we've got a similar situation, but I noticed that there's a negative sign that's flip-flopping back and forth. So that means our R value is going to be negative. My A value is negative 2. So I notice each time it's multiplying by 3, but it looks like it's multiplying by negative 3 because the sign is changing. So my R value is going to be negative 3. Let's make our general term. So there's my general term. And now if I want to get my 9th term, I got to plug in a 9. So you could do negative 3 to the 8 on your calculator. I would probably just do 3 to the 8, and I would recognize that since it's an even exponent, that means all those negatives are going to cancel out. And so that's going to be 6,561. So we multiply that by -2, multiply our answers together, we're going to end up with negative 13,122 is our ninth term. Okay, so I suspect you found that going up with geometric series much easier than series that are going down, where you have to deal with a fraction as your R value. So much easier if we're going up rather than going down. Okay, that was all the examples I wanted to show you today for our geometric series. So I'm going to stop the video here, and I want to move on to our next lesson, which is going to be on something called recursive sequences or recursive formulas. Now, you've seen these mentioned before in the book, and I always said just don't do anything with them. We're gonna now understand what that means, and I'm gonna want to start with a really famous, probably the world's most famous number sequence called the Fibonacci sequence.